Okay, where we left off before we balanced equations, we were looking at the symbols, and we got to one, and I feel a little guilty because I didn't take the time to explain it in detail, so I want everybody to think. So the last thing we wrote was, don't know why it's taking so long. It does not like this next one. Okay, last thing we wrote was, if I put a chemical above the arrow, it was a catalyst. Okay, above the arrow means it's not a reactant. It doesn't get used up. It's not a product. It doesn't get made. Well, if I don't use it and I don't make it, what the heck is it doing in the reaction? Okay. So you've studied catalysts before, you just didn't call them catalysts. We had a different name for them last year in biology. Okay. So what is a catalyst? Why is it on top of the arrow, not a reactant, not a product? Hey, it's on the arrow because it's without being changed by the reaction, so it doesn't get changed. All it does is it takes the reaction that's going to happen anyway and makes it happen faster. So it takes the reaction that was going to happen and makes it happen faster. It's not too bad. Right? The place where you use catalysts. Well, the most common example, the easiest example to come up with is in a catalytic converter. In your car, before the exhaust comes out of the tailpipe, it passes through a box called a catalytic converter. Okay, so the exhaust gas comes out, there's a box, and inside that box is a fine mesh covered with platinum and palladium. Okay, so the gas has to go through that fine mesh before it leaves. And here's what they're doing. Here's why they're fighting. They're fighting smog, air pollution. Because when you heat up the air inside the cylinder of a car, the nitrogen and the oxygen can react with each other and make NO2. On a summer day, you look out across this valley and it looks brown. The brown color is because of NO2 in the air. It's brown gas. Okay? So you see that NO2 in the air. Well, NO2 is bad for you. It's a pollutant. We don't want to breathe it. So they put catalytic converters in so that when the exhaust gas comes in, the NO2 will eventually fall apart by itself. Pollution goes away if you just leave it out in the air long enough, but it takes days. Okay? But by passing it through that catalytic converter, they can make it happen so fast that it happens before it leaves the car. Okay? So you know NO2 comes out the tailpipe because it speeds up the reaction so fast that it happens before it leaves, which is a good thing because I don't want to breathe NO2. Okay? So that's what catalytic converters do, and the reason why they're expensive is because they're full of platinum and palladium. Platinum and palladium are really expensive metals. So that's why we don't use leaded gas. When you go to the gas station, you always buy unleaded. Also, why that? Well, they used to put lead in the gas to change how fast it went, but when you went to the catalytic converter, you couldn't use lead anymore because the lead would get through the gases and then just cover the platinum and palladium. They get coated with lead, and if they're coated with lead, then the platinum and palladium aren't touching the gas, so they don't catalyze. Your catalytic converter stops working. And you go to get your smog check, and they say you fail, and you have to replace your catalytic converter at $750 to $2,000. So that's why you don't want to put leaded gas in an unleaded car. Okay? You studied these last year, but you didn't call them catalysts, you called them enzymes. Enzymes were protein catalysts. My favorite catalyst, my favorite enzyme, is the one in fresh pineapple. Anybody ever eaten a whole bunch of fresh pineapple? Your mouth hurt, didn't it? You say, well, why is my mouth hurting after I'm eating fruit? What's going on? Well, fresh pineapple has an enzyme. That enzyme speeds up the breaking of the peptide bond, the thing holding proteins together. So it's breaking the amino acids apart in proteins. Because proteins naturally fall apart, it just takes a long time. So by putting that, with that enzyme in your mouth, it happens in your mouth, and the proteins in your mouth fall apart into amino acids. So it's digesting your mouth. All the proteins, that's why cheek hurts is because the proteins have fallen apart and those cells are dying. All the proteins are falling apart. That means you can't, the real test is you can't make Jell-O with fresh pineapple. Jell-O is a whole protein matrix holding on to water. But if you put fresh pineapple in, it tears apart the bond that makes the proteins, so the proteins never form, and it will never set, because as soon as you get a protein, the enzyme speeds up falling back apart. Okay? So if you see pineapple in your Jell-O, you know they used canned pineapple. Because in the canning process, they heat it up, and heating up destroys proteins, including the ones that are enzymes. So the enzymes get destroyed when they heat up the can, so it doesn't tear it apart. If you want to find that enzyme, the easiest way to find it is go to the grocery store and look for meat tenderizer. That's what it is. The enzyme in pineapple is meat tenderizer. That's tenderizing your mouth, dissolving it. Okay. Same enzymes in kiwi, but. All right. What we're going to do today is take words and change them into balanced equations. Okay? So this is a sentence that describes a reaction. I took solid iron 3 sulfide and I reacted it with gaseous hydrogen chloride. I formed solid iron 3 chloride, hydrogen gas, and sulfur. Write the balanced equation for that reaction. So it's really just writing and naming formulas, writing names and formulas, and then balancing, right? Just names and formulas like we've done before, and then balancing. So first I start off with solid iron 3 sulfide. Well, that Fe, that 3 isn't how many Fe's there are, it's the charge on Fe. Fe is 3 plus. Sulfide is sulfur off the table because it's got the IDE ending, and sulfur's in group A, or 6A, so it's 2 negative. So the right formula for solid iron 3 sulfide is Fe2S3. Do the crisscross. And to say it's solid, I'll put an S in parentheses after it. So I have just written solid iron 3 sulfide. Reacts with plus. There's going to be another chemical there. Gaseous hydrogen chloride. Hydrogen, chloride. H is, it doesn't have prefixes, so expect me to use charges. H is 1 plus, Cl is 1 minus. So that's hydrogen chloride. And to say it's gaseous, I'll put a G. To form solid iron 3 chloride. So it's iron 3, so that means iron 3 plus. Chloride is Cl with a 1 minus charge. Those don't add up to 0, so we crisscross, get FeCl3. And to say it's solid, I put an S there. And sulfur and hydrogen gas. And that's almost right. Something's wrong here. And I've mentioned it before, but it's going to come up now that you have to start writing these things. Remember the diatomic molecules? The 1 and the 7? That I'm never going to find hydrogen by itself. I'm never going to find oxygen by itself, or nitrogen, or fluorine, chlorine, bromine, iodine, or astatine, that when they're by themselves, they get a 2. Diatomic, 2 atoms. So if I go back up to the one I just did, can sulfur be by itself? Is sulfur one of those 1 and 7? Let's look and see. Where's sulfur on the periodic table? Sulfur is here. So is it one of the ones that's diatomic? No, so I can write just an S. Okay, is hydrogen one of the ones that's diatomic? Is hydrogen diatomic? Is it one of the ones? It's number 1, right? So 1 and 7, so number 1. So I shouldn't write H, I should write H2. So on tonight's homework, when you see something by itself, you have to decide, does it get a little 2 or not? Most of them don't. But 8 of them get little 2s afterwards. So now I have translated this sentence and this equation say exactly the same thing. I included everything. I included every state of matter they mentioned, right? So it's described, so I've just taken that sentence and shortened it to letters. Now I need to balance it. Okay, so we go to balance it. I've got 2 irons on my reactant side. Do I have 2 irons on my product side? So I would have to put a 2 there, wouldn't I? Now that's going to give me 6 chlorines. How can I get 6 chlorines on the reactant side? Well, there's the chlorine on the reactant side. I'd have to put a 6 there. So it gives me 6 chlorines and 6 chlorines. FeCl3, if I have 2 of those, that's 6 chlorines. And 6 HCl's would be 6 chlorines. Okay. So it looks like I'm done, but I'm not. Because I want to check one last time. 2 Fe's, 2 Fe's. 6 H's, oh, I don't have 6 H's, so I got to put a 3 in front of H2 to get my 6 H's. What about my 3 S's? Don't have my 3 S's either, do I? What about my, well, 6 Cl's, 6 H's, 2 Fe's, 3 S's? That's it. So see, all it is doing names and formulas like we did last week, and put it in an equation so we can balance it. Does that make sense? So that's what I'm going to have you do. Talking about it makes says, wow, Mr. Green can do that really easily. But that's not the goal.